All right, 8.6 natural logarithm. Let's dive right in. So what are we going to learn? We're going to learn to evaluate natural logarithmic expressions, and secondly, we'll solve those equations using natural logarithms. So the only new vocab in here is natural logarithmic function. Everything else involves things we already know how to do. So just one small addition. Everything else should be refreshers of things we already know how to do. So the video, try the skills, check, and we'll get ourselves started here in a second. All right, so what is this natural logarithm business? So we learned previously about this number e. All right, so e is going to be used as a base for exponents, and e is approximately 2.71828. The function y equals e to the x looks like this, the curve going up, just like a normal exponential function. All right, now we've also learned about inverses. So if we remember about inverses, if we had y equals e to the x, the inverse of that would be x equals e to the y. Write that better, x equals e to the y. Now, if we had to get y by itself again, remember that we're going to rearrange using logarithms. So we would say log base e of x equals y. All right, and we have a special phrase for log base e, and that's natural logarithm. All right, so log base e is the natural logarithm. We write it as ln, natural logarithm. Okay, if you can figure out why the letters are reversed, super duper brownie points for you. We could talk about that in class. So natural log of x equals y. So the natural log is the inverse of e to the x. Let's try a few problems here. Now, knowing that, everything else is the same. The properties of common logarithms are the same as for natural logarithms. So, if we have a problem, 3 natural log of 6 minus natural log of 8, what could we do? Take that 3, move it to the top. Power property, natural log of 6 cubed minus natural log of 8. All right, 6 cubed happens to be 216. Let's clean that up first. Now, quotient property, 216 over 8, and 216 divided by 8, check it on the calculator, is 27. So we would have the natural log of 27. All right, so you could put that into your calculator to approximate it, but we're going to leave it just like that with an exact value. All right, couple for you to try. Let's use a real-world example. A spacecraft can attain stable orbit 300 kilometers above the Earth if it reaches a velocity of 7.7 kilometers per second. So this is our goal. We're trying to get to 7.7 kilometers per second. The formula for a rocket's maximum velocity v in kilometers per second is v equals negative 0.0098 t plus c natural log of r. We're going to need that formula. The booster rocket fires for t seconds, and the velocity of the exhaust is c kilometers per second. The ratio of the mass of the rocket with fuel to its mass without fuel is r. So those are what all the variables stand for. Suppose a rocket used to propel a spacecraft has a mass ratio of 25. All right, so that's r. An exhaust velocity of 2.8, that's c, and a firing time of 100 seconds. Can the spacecraft attain a stable orbit? Let's plug it in and find out. V equals negative 0.0098. The time in this problem was, where'd you go? 100. Plus C was 2.8 times the natural log of 25. All right, into the calculator we go. Let me actually pause this for a second and I'll bring up the calculator. Click the things open here. Where's my timer? There we go. All right, so let's plug this in. Negative 0.0098 times 100 plus 2.8 times natural log right here. Notice that it's right below the e to the x. So they're inverses of each other. Natural log of 25. We plug that in, we get 8.03. All right, we needed to get to 7.7. We got to 8.03, so yes, we are going to be able to maintain our orbit. All right. Try it on understanding check number 2. Okay, let's try some more properties here. Solving for x. All right, on this one, natural log of 3x plus 5 squared equals 4. We need to get x by itself. It's currently inside of a natural log. Got to get this 2 out of here first, because you can't rearrange this until the natural log is all by itself, and this 2 is hanging out on the same side. So we're going to bring it in front. 2 natural log of 3x plus 5 equals 4. Let's divide by 2. Natural log of 3x plus 5. 4 divided by 2 is 2. And now we can rearrange this, because remember, natural log is the same as log base e. So we're going to rewrite this as e squared, right? E to the power of 2 equals 3x plus 5. Just rearranging our logarithms. All right, let's solve for x. We're going to subtract 5. We're going to divide by 3. And there you have it. All right, your turn. Let's try one more, trying to get x by itself. So first step, subtract 2.5. Divide by 7. And that turns into 2.5, actually. Now, how would we get e out of here? Rearrange this. This is log base e of 2.5 equals 2x. And remember, instead of writing log e, we're going to write natural log 2.5 equals 2x. So just one step left. Get the x by itself. You're going to divide by 2. Not natural log of 1.25. Don't divide the 2.5 by 2. The entire natural log gets divided by 2. All right, let's remember our formula for investing. A equals P times E to the RT. An initial investment of $100, that would be our P, is now valued at $149.18. So that's how much the A is, the total value. And our rate is 8%, so we're going to write 0.08 times T. So previously we wouldn't have known how to solve this, but now we can. Let's divide by 100. 1.4918 equals e to the 0.08t. How do we get this e rearranged? We're going to write natural log of 1.4918 equals 0.08t. We're going to divide by 0.08 to get the t. Let's grab the calculator. And so we'll say natural log of 1.49. Did I forget a 1 in there? I did. 18. Close your parentheses. Make sure you do that. And then divide by 0.08. And we have 4.9997, so just about 5 years to make that grow from $100 to $149.18. All right, yours to finish, number 5. I believe that's it. Yes, it is. All right, so finish up number 5. Any questions, ask them in class. Good luck.